In exercise 5, we have something a little to tease the taste buds of our engineers in the group. This is a typical problem in whether or not the system will function given the probability that dependent systems function. We read, a system contains 4 components, at least 3 of which must function in order for the system to function. At a given time, the number of components n that are not functioning has the probability distribution given below. So top row is the n, the number that are not functioning, and the bottom row is the probability of that number not functioning. What is the mean number of components functioning at any time is part A. Well, to be able to solve this one, we can simply go back to the idea of calculating a mean within a probability distribution. And I've done it here using the sum product. Now the only difference here than how you've done other problems is the arrays are in rows as opposed to columns. But that's still fine. Sum product can still handle it. So the row of B20 to F20 times the row or the array of B21 to F21 yields the mean in cell, what is that, B23. Okay, so there's the mean. Now once again, the formula for calculating the standard deviation has a couple of steps. I'm going to review them here. The formula was given in your books, and it's the sum product of the square of n, so n squared, and the probability of not functioning, B21 to F21, minus the mean squared. Now that's a tough one to remember. You probably have to look that up every time you're going to want to use it. So that's why the template is there and helpful. Now, once that variance is calculated, you take the square root of it. Square root of the variance is equal to the standard deviation. And that's in cell B25. So the standard deviation is 1.74 and the mean is 1.46. So the mean number for A, what is the mean number of components functioning at any time? The answer is 1.46 for the mean number that are not functioning. Therefore, if you want to calculate the mean number that are functioning at any time, you would use 100, or you would use 4, the total number of components, minus those that are not functioning, which is 1.46. So you get 2.54. So the answer to part A is 2.54. Part B. What is the standard deviation of the number of components functioning at any time? The standard deviation of the number of components functioning at any time. Well, we would calculate the mean of the squared values of n and subtract off the square of the mean. That's what we see here. This gives a variance of 3.03 and a standard deviation of 1.74. And we can use the probability template to do this. Now, if I were using the probability template, here's what I would do. I would select these first, 0, 1, 2, 3, 4, Command C for copy, and then I would go over to the probability template. You see it still has the values from a previous problem. So let's delete those. And right here, I'm going to right click and say paste special. Well, it lost the fact that I still have them there. So let me go back to the other document, book 1. Select these. copy, and then go to the template and right click and say paste special transpose. Now why do I put transpose? Transpose, and I'm actually going to hit Command Z and do that again, Command paste special, and I'm going to click on paste special down here at the bottom so that I can do more than one thing at once. There's a dialog box. I want it to put just the values in and to transpose them. Okay, so that way it doesn't mess up the whatever formatting is there. And the formatting is not right for this one, so I need to get rid of the formatting there that is in dollars and change that formatting to just a number. Oh dear. See if I can do it. Might be that the sheet is protected, so it's not letting me do it. Well, by the same token, I could go over to the window for book one and take the probabilities, which are here, copy them, and go to book one. No, go to the probability distribution, and right click here and say paste special, and put in just the values and transpose them. Okay. So there I get my numbers. This is what the distribution looks like. The mean is once again 1.46 with a variance of 3.0 and change. And the standard deviation is 1.74. So that's another way of calculating it. So we go back to book one to finish the problem out. What is the probability that the system functions? Well, the probability that the system functions, it functions so long as the number of failed components is 1 or less. So it only functions if there are 0 or 1 that have failed. So we would say the chance of this is 0.55 plus 0.05, which is 0.6. So one might have expected that since the mean number of failed components is greater than 1, that it would be more likely than not that the system would fail. But that would confuse the mean with the median. So we calculate the probability of the system that the system fails is equal to the sum of the probabilities that 2 parts fail plus 3 parts fail plus the probability that 4 parts fail. So that is equal to 40%. So 40% that it fails, 60% that it doesn't fail. And that's how you work problem exercise number 5.